Welcome back to NAROJ Masters Academy. Today we are going to discuss the lecture number 6 of electricity. Okay. In this lecture, we'll discuss the problems based on the Ohm's law and other concepts. Okay. So numericals based on the type C, that is equivalent resistance when they are connected in series and equivalent resistance when they are connected in parallel. Okay. So a battery of 9 volts is connected in a series with a resistance of 0.2 ohms, 0.3 ohms, and 0.4 ohms, and 0.5 ohms and 12 ohms respectively. How much current would flow through the 12 ohms resistors? First of all, what they said in the question is they are connected in series. Series means in all the resistors the same amount of current will flow. Is it right? So first we have to calculate the total amount of equivalent resistance of the circuit, and then battery is given. Is it right? So first step is to total resistance is 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12, that equal to 13.4 ohms. Is it right? Voltage is given is 9 volts. Then we know that V is equal to IR formula. Okay, current is equal to question mark. Then from that I is equal to what? V by R. Is it right? So V is 9 and R is 13.4. The final resistance, final current is 0.67 amperes. So the same amount of current is flows through the 12 ohms resistor. Is it right? So the current through 12 ohms resistor is equal to 0.67 amperes. Next question. Just the equivalent resistance when the following are connected in parallel. 1 ohm and 10 power 6 ohms. When they are connected in parallel, we know that 1 by R1 plus 1 by R2. Is that right? So 1 by R1 plus, that is 1 by 1 plus 1 by 10 power 6. So equivalent resistance is 10 power 6 plus 1 by 10 power 6, that equal to almost 10 power 6 only. Is it right? So almost 1 only. So equivalent resistance is equal to 1 ohms but less than 1. Is it right? So always it is less than 1. And 1 ohm, 10 power 3 ohms and 10 power 6 ohms are connected in parallel, means 1 by 1 plus 1 by 10 power 3 plus 1 by 10 power 6. Is it right? 10 power 6 is the LCM and we have to take 10 power 6 plus 10 power 3 plus 1. So here it is again, we can say that the equivalent resistance is less than 1, that is 0.9999 ohms. Is it right? Next question. An electric lamp of 100 ohms, a toaster of resistance 50 ohms, and a water filter of resistance 500 ohms are connected in parallel to the 220 volt source. What is the resistance of the electric iron connected in to the same source that takes thus as much as current of all the three appliances, and what is the current through it? See, first of all, if we calculate the amount of current flowing through these all three circuits, the same should be flows through the iron box, because it is also having the same source and it takes same amount of current. Is it right? So here three resistors are given, voltage is given. So first of all, let me find the equivalent resistance. 1 by R1 plus 1 by R2 plus 1 by R3. Is it right? So equivalent resistance is 1 by 100 plus 1 by 50 plus 1 by 500, that equal to 500 is LCM. So equivalent resistance is how much? R equivalent is equal to 500 by 16. Is it right? When we reverse it. So according to Ohm's law, V is equal to what? IR. Then from this, I is equal to V by R. V is 220 and R is 500 by 16. That equal to 7.04 amps. Okay. So these three, all the three appliances together draws the total amount of current is 7.04 amperes. Is it correct? Now our question is not yet over. What is the resistance of the electric iron? He asked. Okay. So resistance of the electric iron is also equal to the sum of this resistance. Is it right? So potential difference is how much? 220 volts only. Current drawn by this iron is how much? 7.04 only. Then V is equal to IR. R is equal to what? V by I. V is 220. I is 7.04. So that equal to 31.25 ohms. Is that right? So both are same. 500 by 16 and this one. Both are equal only. Okay. So resistance of the iron box is 31.25 ohms and the current flows through the iron is 7.04 amps. Okay. If you are not understood this question, you can read the question carefully. How can three resistors are connected? 2 ohms, 3 ohms and 6 ohms, so that the total resistance will be 4 ohms or 1 ohm. Two questions are there. To get 4 ohms, first of all we have to cross check with the circuit diagram. Okay. If you add 3 out of 3, 2 plus 3 plus 6, it will be equal to how much? And 8 plus 3, 11 ohms. It is not correct. So we are not supposed to connect in series. Okay. Look at here. Very interesting question. This questions may ask in board exam as well. So here 2 ohms, 3 ohms, 6 ohms, 2, 3, 6. So if it is in series, 2 plus 3 plus 6, that is equal to 11 ohms. So here there is no option to get 11. So we are not supposed to connect it in series. So let me do one thing. Let me connect first two are in parallel, 2 ohms and 3 ohms. Okay. And another is in series, 6 ohms. So 1 by 2 plus 1 by 3, that equal to how much? 5 by 6 or 6 by 5 plus 6. So here also we are not getting 4 or 1 ohm. Is it right? 5 by 6 is how much? Here 530 plus 6, 36 by 5. So we are not getting here again 1 by 6 or something. And let me connect 3 out of 3 are in parallel. 1, 2, 3. We have to cross check like this. 2, 3 and 6. So 1 by 2 plus 1 by 3 plus 1 by 6. So LCM is 6. So this is 1 by R parallel. So here 2 3 times, 3 2 times, 6 1 times. So this is 6 by 6, that equal to 1 ohm. So 1 ohm we got this question. For second bit we have to connect 3 out of 3 are in parallel. Okay. And let me connect 2 ohms is in series and remaining two are in parallel, 6 ohms and 3 ohms. Okay. So this is 6 and this is 3. So here 2 plus this is 1 by 6 plus 1 by 3. Okay. So what is the value of this? LCM is 6, 6 1 is 6, 3 2 is. Okay. So this is 1 by R actually. So here 3 by 6, that equal to, then R is equal to 6 by 3, 3 once, 3 2 times. So here its value is 2 and its value is 2. 2 plus 2 is 4 ohms. So we have to connect this one circuit and this is another circuit. Okay. For the first bit, we have to connect 6 and 3 are in parallel and 2 is in series. And for the second bit, we have to connect 3 out of 3 are in parallel. Is it clear? So here you can see that for the first bit to get R equivalent equal to 4 ohms, the circuit as shown in the figure R2 and R3 are in parallel. Okay. And for the second bit, we have to connect 3 out of 3 are in parallel. Is it clear? Yeah. An electric lamp whose resistance is 20 ohms and a conductor of 4 ohms resistance are connected to a battery of 6 volts battery. Calculate the total resistance of the circuit. Okay, one conductor is there and one lamp is there. Okay, conductor resistance is 4 ohms, lamp resistance is 20 ohms. So here total resistance of the circuit is how much? R is equal to, where they are connected in series, R1 plus R2. Is it right? So 20 plus 4 equal to 24 ohms. Second bit, the current through the circuit, I is equal to what? V by R. Is it right? So V is 6 volts, R is 24. So that equal to 0.25 amps. And C, the potential difference across the electric conductor and lamp. Electric conductor means R2. Potential difference is nothing but what? V. V is equal to question mark. V1 is equal to I into R1. I is how much? 0.25. And R1 is how much? 20. So answer is 5 volts. And what about the bulb? Across the the first one is electric lamp. So okay, R1 is 20 ohms here for the lamp. And R2. Here I into R2. I is 25, 0.25. R2 is 4. So it will be 1. Is that right? So 1 volt. So with this question is also over. In the circuit diagram given, the suppose the resistors R1, R2 and R3, I have the values 5 ohms, 10 ohms and 30 ohms respectively, which have been connected to a battery of 12 volts. Calculate the current through each resistor. Okay, the total current and the total resistance. First, all values are given, R1, R2, R3 and voltage is also given. We have to calculate current through the circuit. First question, is it right? I is equal to what? I1 plus I2 plus I3. So we have to calculate first equivalent resistance. Is it right? Equivalent resistance is equal to what? LCM is 30. So 5 6 times, 10 3 times, 31 times. So here it is 10 by 30. RP is equal to 30 by 10. Then RP is 3 ohms. Equivalent resistance in parallel is 3 ohms. Is that right? Then we can find the current here. You can see that I1 is equal to V by R1, that is 12 volts battery, and R1 is 5 ohms, and then that is 2.4. I2 is equal to what? Current in the second resistor V by R2, that is 1.2 amps. I3 is equal to what? V by R3, that is equal to 0.4 amps. And next bit is the current, total current is I1 plus I2 plus I3, that is equal to 2.4 plus 1.2 plus 0.4, that is equal to how much? 4 amps. Last question, the total resistance, that is effective resistance. Is that right? RP, that is 3 ohms only. Effective resistance in parallel is 3 ohms. So the final answer is total resistance is 3 ohms, total current is 4 amps, and the current in each resistor is 2.4, 1.2, and 0.4. Is it right? The circuit diagram R1, R2, R3, R4, and R5 are connected in a battery with a battery in the arrangement as shown in the figure. Is that right? Find the total resistance. Very easy. And the total current flowing. Total resistance means first two R1 and R2 are connected in parallel. So find the sum of these two. It is R1 by 1 by R1 plus 1 by R2. And then again find the value of 1 by R3 plus 1 by R4 plus 1 by R5, and then connect these two are in series. Okay. 1 by R1 plus 1 by R2 is how much? 1 by 10 plus 1 by 40, that equal to 4 plus 1 by 40, that equal to 5 by 40, 40 by 5, that is RP is equal to 8 ohms. So at this we got the total resistance of this setup is 8 ohms. Okay. Now we have to calculate for this. Let RP2. Okay, 1 by R3 plus 1 by R4 plus 1 by R5. The sum of the resistance is equal to 1 by 10 means 10. So its value is how much? 10. Its value is 10. Its value is 8. Okay, both are connected in series now. So 10 plus 8 is equal to 18 ohms is the equivalent resistance. Is it clear? So equivalent resistance is how much? 18 ohms. The total current. We know that V is equal to IR, I is equal to V by R. V is how much? 12 volts. Current is 18. So 2 by 3. That equal to 0.67 or 66 amperes. Is it right? So how you would like to connect three resistors in each of resistors are 6 ohms, so that the combination has to be resistance of 9 ohms and 4 ohms. So we are having three resistors R1, R2, R3. So each value is 6 ohms only. Is it right? So if you want to connect in parallel, then 1 by 6 plus 1 by 6 plus 1 by 6, that equal to 3 by 6. So 2 you will get. You will not get 9 or 6, 9 or 4. Is it right? So no chance. If you connect in series 6 plus 6 plus 6, you will get 18. So no chance. So how to connect to get 9 ohms or 4 ohms? Check it here. So here 1 by R1 plus 1 by R2 plus 1 by R3 is not possible. Okay. So we have to use these two formulas only to cross check. To get 9 ohms, R1 and R2 are connected in parallel. Okay. Then 1 by 6 plus 1 by 6, that equal to 2 by 6, that equal to 3 here. Now R3 has to be connected in series. Then 3 plus 6 is equal to 9 ohms. Is it right? So the diagram of for this first bit is first two are in parallel and one is in series. Okay. So this is 6, 6, 6. 1 by 6 plus 1 by 6, its value is 6 by 2, and finally it is 3. Its value is 3 and it is 6. 3 plus 6 is 9. Is it right? For the second bit, to get 4 ohms, R1 and R2 are connected in series. So 6 plus 6 is 12, and R3 has to be connected in parallel. So it means this time series, series, and it has to be in parallel with this. So, like this. 6, 6, 6. 6 plus 6 is 12. So here it is 12, it is 6. So 1 by 6 plus 1 by 12. Okay. So that equal to 3 by 12, that equal to 4 ohms. Is it right? So in this way, we have to connect the resistors to get the 9 ohms and as well as 4 ohms. So what is the highest and the lowest total resistance that can be secured by the combination of the four coils of resistors? Highest only possible when they are connected in series. 4 plus 8 plus 12 plus 24. Is it right? Lowest is possible only when we connect these all are in parallel. To get the highest one, we should connect in series, 48 ohms. And to get lowest, we should connect them in parallel, 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. Is it right? So this is 1 by 2, that is 2 ohms. How many 176 ohms resistors are connected to carry 5 amperes on a 220 volts line? So here each resistor value is 176 ohms. So how many such type of resistors are required to carry 5 ampere current on a 220 volts line? Okay. First of all, we know that voltage is 220 volts, current is 5 amps, resistor is R, that is 176 ohms. First, number of resistors we have to calculate. V is equal to IR formula, then R equivalent is equal to R by N. So number of resistors is equal to N is equal to R by R equivalent. Okay. So first of all, let me calculate R equivalent. So V by I, V is to 20, by I is 5 amps, so 44 ohms. R equivalent is how much? 44. R equivalent is 44 ohms. Then substitute in this formula. N is equal to R by R equivalent. R is 176 and R equivalent is 44. Then we'll get the answer as number of resistors required is 4. Is that right? So very important type of question. Thank you.